Hello guys, this is Teacher Jackie once again, and I am here to help you in some topics in statistics and probability. Our lesson for today is finding probabilities using the standard normal table.
After watching this video, you will be able to find probabilities for the standard normal random variable, express areas under the normal curve using probability notation. Before we proceed to our lesson, we have to check your knowledge on probability distribution and normal curve by answering the following questions. Which of the following best describe the given normal distribution shown on the figure? The probability of the distribution is letter A, no more than negative z, or B, between negative z and 0, or is it C, at least negative z, or is it D, equal to negative z? So the answer is, the probability of the distribution is at least negative z. Which of the following normal curves describe the probability is not greater than negative z? Is it A, or B, or C, or D? The answer is letter D. Are you familiar with this formula? Yes, this is the z-score or standard score formula. That is z equals x minus mu divided by sigma, wherein x is equal to the raw score, mu is the mean, sigma is the standard deviation, and z is the z-score. Mathematical notations are very effective and helpful in finding the probability under the normal distribution curve, especially for lengthy expressions. You can see on the screen the mathematical expressions and their corresponding meaning. For example, we write the mathematical notation of the area between z1 equals 1 and z2 equals 2. So we write the mathematical expression and change z1 and z2 to 1 and 2. This is read as the probability that the z-score is in between z1 and z2 is 0.1359. The keywords above z1, to the right of z1, at least z1, greater than z1, more than z1, not less than z1, have the corresponding mathematical notation, and bell curves where the shaded portion is everything under the curve that is to the right of z1. The keywords below z1, to the left of z1, at most z1, less than z1, not greater than z1, have the corresponding mathematical notation, and bell curves where the shaded portion is everything under the curve that is to the left of z1. The keyword between z1 and z2 has the corresponding mathematical expression and bell curves. Ang shaded portion under the curve ay ang area na nasa gitna ng dalawang z-scores na nabanggit. When we say normal curve or bell curve, the important part is the area bounded by some values. This area bounded under the curve is the same as the probability. We know that the total area of a bell curve is equal to 1, and the z-score at the middle of the normal curve is 0. If we have to find the probability wherein z is less than 0, then we will shade half of the bell curve that is to the left of z equals 0. Then the probability is equal to 0.5, since the probability of the entire normal curve is equal to 1. In research, however, we are not only solving for half of the normal curve, but there are instances that solving for the area or probability needs some knowledge in calculus. But the good news is, mathematicians develop a table which is called the z-table or z-score table. This table of values was developed to make calculations easier. So let us now solve the area using the standard normal table. For this example, we find the area below z equals -2. We must first draw the corresponding normal curve and shade the required area. Hahanapin natin sa standard normal table ang area or probability of the z-score na -2. Paalala, maraming versions ang standard normal table, pero ang gagamitin nating standard normal table ay ang nakikita ninyo sa inyong screen, kung saan ang mga values na makukuha natin ay palaging between 0 and the z-score value. At kung mapapansin ninyo ay walang negative sign ang mga z-score na yan. Yan ay dahil ang normal distribution curve ay symmetrical. Ang pinakaunang column at row ay naglalaman ng ating z-score value, kung saan ang ating z-score value ay rounded off sa 2 decimal places. The first column indicates the whole number and the value of the first decimal place of our z-score. Ang row naman, kung mapapansin ninyo ay second decimal place lang ang nagbabago. Yan naman ang value ng second decimal place ng z-score. In the given example, we need to find the area below z equals -2. Lalagyan natin ng dalawang decimal place na equivalent sa 0 ang value na ito para mahanap ang intersection ng column at row sa ating standard normal table. The intersection of z-score value of 2 was found to be 0.4772. Ang tanong, ito na ba ang area below z equals -2? Hindi pa ito ang area na hinahanap natin. 0.4772 is the area between z equals 0 and z equals -2. Alam natin na ang area below z equals 0 is 0.5. Para ma-solve natin ang required area, we will just subtract 0.4772 from 0.5. So the area below z equals -2 is 0.0228. Sa example naman na ito ay hahanapin natin ang probability above z equals -1.56. Gaya ng ginawa natin sa unang example, we will draw the normal curve and let us shade the required area. Then let us find the value equivalent to z equals -1.56 from our standard normal table. We found the intersection of the z-score value to be 0.4406. Is this the required area? No. This is just the area between z equals 0 and z equals -1.56. Nakikita ninyo sa ating normal curve na ang kalahati nito ay mayroong shade. At ang natitirang shaded portion ay ang area between z equals 0 at z equals -1.56. Para makuha natin ang required area, pagsasamahin natin ang mga areas na nabanggit. We will just add 0.4406 and 0.5. It will give us 0.9406. So the probability above z equals -1.56 is 0.9406.